Welcome back. In this video, we're going to solve quadratic equations using square roots. So let's take a look at standard form of a quadratic equation and review that again. Standard form is any quadratic that's in the format of ax squared plus bx plus c equals 0, where a is the coefficient on x squared and b is the coefficient on x and c is our constant. So in the past, this was the format we needed in order to factor this. So let's say we have a quadratic that's x squared minus 9 equals 0. It's already in factorable form. We'll work with something here where b is 0. So we have no linear term. So we can solve for x by factoring and using the zero product property. So we're real familiar with factoring x squared minus 9 into x plus 3 times x minus 3 is still equal to 0. And then using the zero product property, we have to set each factor equal to 0. Right, so x plus 3 equals 0. So if x plus 3, that factor becomes 0, the whole equation collapses to 0. And x minus 3 equals 0. So sure enough, we get x equals negative 3 and x equals positive 3. So we see here we get our two values for x. And in fact, what we have found here when we factored is we've got the x-intercepts or the roots or the solutions of some particular parabola. Okay, so these are the x-intercepts of the parabola. So every time we factor a quadratic, we are finding the x-intercept. So our parabola might look something like that. So that's something important to keep in mind. So if we have a quadratic equation in which b is equal to 0, we can solve by factoring, or we can solve by using the inverse operation of squaring. So we had x squared. Well, we want to get the x out from underneath the square, just like we tried to expose it from underneath the square root before. So we want to isolate x squared. We want to get x squared all by itself. And then we would take the square root of the number on both sides of the equation. So a simple one like we just did, x squared minus 9 equals 0, well, we'd add 9 to each side and we get x squared equals 9. And then we take the square root of both sides. But you have to remember we get two different solutions. So our temptation here is to say x equals 3, which is true, but that's only half the answer, right? You notice that when we factored, we got x equals negative 3 and positive 3. So you'll see here, really our answer should be x equals plus or minus 3. So we must use the plus or minus when we take the square root of both sides. So let's move on to some sample problems. And let's go ahead and factor these. So this one should be pretty straightforward. We'll add 49 to both sides. We'll get x squared equals 49. Take the square root of both sides, and we get x equals plus or minus 7. And we can check by even just putting negative 7 back in for x. Is that the case? Well, sure enough. Negative 7 squared is positive 49. So we get 49 minus 49 equals 0. So it does check out. The second one, we have 3x squared equals 11. Well, I certainly don't want to take the square root of 3 here. So we would divide both sides by 3, leaving us with x squared equals 11 thirds. Now we want to solve for just x, so we use the inverse operation. We take the square root of both sides, and we get x equals plus or minus the square root of 11 over the square root of 3. Now you may recall we don't like square roots in our denominator. We don't like this irrational, so we have to rationalize that. Well, since it's a square root, we can just multiply each side, the numerator and denominator by radical 3, and we get x equals plus or minus the square root of 33 all over 3. Let's take a look at our next sample problem. The quantity x minus 4 squared equals 49. Well, this particular problem, we have a perfect square trinomial. And of course, a perfect square trinomial is a perfect square, so we can take the square root of it. We've got any quantity that we can take the square root of here. Any quantity squared is easy to take the square root. So we can simply, since we have a perfect square trinomial, we can take the square root of both sides. So the square root and the square offset each other. We get x minus 4 equals plus or minus 7. But I want to solve for x. I want to know what x can be. So I'm going to add the 4 to both sides. And I usually add it in front of the plus or minus. I try not to do it on the other side. And you'll see why here. So if we add 4 to both sides, we get x equals 4 plus or minus 7. Now in this situation, I'm going to want to know what that is. So we really get two answers for x. We get 4 plus 7, which is 11, and we get x equals 4 minus 7. So it's important to have that 4, or whatever you add or subtract from the left-hand side, put it in front of the plus or minus. And that equals negative 3. So in this particular problem, we have our two answers for x, our two roots, our two x-intercepts would occur at 11 and negative 3. Since I did one exactly like this next one, the x minus 5 quantity squared equals 18, again, we've got another perfect square trinomial, so we can just take the square root. I'll leave that one for you to do in class, or bring that to class. Now, the next sample problem, 2 times the quantity x plus 3 squared plus 15 equals 5. Again, we want to clear everything away from x. You may notice we have the perfect square trinomial here, but let's go ahead and clear things away from that. So I'm going to subtract 15 from both sides. So I get 2 times the quantity x plus 3 squared equals negative 10. Go ahead and divide by 2 and get that 2 out of there, 2 times that whole quantity. We'd have to square all that first. So there's really no reason to multiply all this out. Okay, we don't need to multiply out our perfect square trinomial. And we get the quantity x plus 3 squared equals negative 5. And I'll take the square root of both sides. And that leaves us with x plus 3 equals the square root of negative 5. Well, we've already worked with imaginary numbers, so that is simply plus or minus, right, because I took the square root of both sides, I times the square root of 5. And then I have to subtract 3 from both sides. And my final answer becomes x equals negative 3 plus or minus I square root of 5. And this final problem that we haven't done is similar to that as well. I'm going to leave that for you to bring that to class as well. So one final note, as you can see, now we have two methods for solving quadratic equations. We can factor, and if b equals 0, the coefficient on our linear term is 0, now we can square root both sides. So we have two methods for solving for the x-intercepts of a parabola, solving for the roots or the solutions. We can factor, and we can take the square root of both sides. So with that, I will see you in class.